Okay, so example 3 says calculate the pH of a 0.40 mole per liter solution of methanoic acid. So guys, again, it's asking us for the pH. If I look at what methanoic acid is, get my data booklet, scroll down, I find it. It's down here, which is below my strong acids. So it's a weak acid. I have to say, boom, okay, I gotta set up ice table, okay? Once I recognize that it is a weak acid, the process is exactly the same. So as we go through this, try to keep in mind how this question relates to the last question. So first thing, I'm gonna try using red. I hope that's okay. All right. It's a little easier to see maybe. So methanoic acid. So you can, if sometimes they won't give you the chemical in your table, and you can use your organic chemistry skills to write it. Here they give it to us and they tell us it is HCOOH. Okay. And we are going to react that with water. All right. It's a weak acid, double arrows, ionizes to produce hydronium and COOH minus. Okay. Again, this is step 1. It's an ice table, so I got to put ice right here. I'm going to put moles per liter up here so I can just put the numbers in. And let's see what we can do. So it wants pH. I want pH, so I want concentration of hydronium. Okay. Initially, all I have is the acid. And how much did I have? I had 0.40 moles per liter. Okay, water's irrelevant. I had no hydronium, and I had none of the anion. Okay, the methanoic acid, so methanoid ion, or whatnot. Okay, so these are my initial concentrations. Are these the same as last question? Yeah, except this was 1, but pretty much the same. If I had no hydronium initially, I'm going to be gaining hydronium. I'll be gaining the products. So both of my products are going up. My reactant is going down. They all have a coefficient of 1. So these numbers are just X. Therefore, my equilibrium concentrations are 0.40 minus X, X, and X. So again, if we want to find the pH, all we have to do is find X. Now, I don't want to find my X. They're out of my life for a reason. All right. God bless her, but I don't need to stir up trouble again. Okay. But we want to find this X. So that was the first thing that we did. Second thing that we can do, guys, is we can write our equilibrium law. Okay. So get more comfortable position. Again, equilibrium law, we have an acid, we're producing hydronium. So I'm going to be doing Ka. Ka is my products. Divided by my reactant, not water, because it's a liquid. Okay. Ka, find it in the DB, the data booklet. I get 1.8 times 10 to the negative 4. Okay, I can write that up here as well, just so I can keep track of it. Okay. That's equal to X times X is X squared divided by 0.40 minus X. All right. This is where I'm at. Do you guys recognize that this is exactly the same as the previous question? Different chemical, same process. We end up with basically the same thing. Different Ka, different concentration. Process has been the same. We recognize that on the bottom, we get into a little bit of trouble. We have that minus X. We want to get rid of that. So we're going to use that approximation. The approximation, again, is basically going to show us that these two concentrations are basically the same. Not much happens, okay? And again, why is that? It's because the reaction is partial. So all I'm going to do is take my initial concentration, HA just means acid, and I'm going to divide by Ka. That's equal to 0.40 divided by 1.8 times 10 to the negative 4. So 0.4 divided by 1.8. Don't forget brackets, times 10 to the negative 4. Okay, don't forget to use brackets. And I'm going to get 2,222, which is significantly above 1,000. So approximation is verified. What does that mean for us? That means we can get rid of that minus x. So I'm going to rewrite it now without that. Get rid of that minus x and rewrite the equation. Now, if you are hopefully in grade 10 or math or above, we can solve this equation. How do I do that? Multiply both sides by 0.4. 0.40. Black marker is really fading. Oh, shoot. I have to rewrite it. Write it in green. Okay. There we go. Okay, multiply both sides by that. This is canceled. So I'm going to get 0.40 times 1.8 times 10 to the negative 4. Again, try to use brackets. Is x squared. Let's square root both sides. So 0.4 times 1.8 times 10 to the negative 4 is this. 7.2 times 10 to the negative 5. Square root that number, and you get 8.48 ... 8.485 ... times 10 to the negative 3. Again, x is a concentration, so it's in moles per liter. And we're there. Has this procedure been any different than the last question? No. It's different numbers. And then the last thing that we're going to do, ladies and gentlemen, is find that pH. pH is negative log concentration of hydronium. I'm going to do it up here. We remember that X is equal to the concentration of hydronium. And guess what? We found X. That was right here. So pH is negative log 8.485 ... times 10 to the negative 3 moles per liter. Let's put that in our calculator, minus log, and I'm going to get 2.0713 ... 2 sig digs in concentration, 2 decimal places, 2.07. All right. Not bad. And that's how we do it. Guys, look at this process, look at this procedure. Okay, learn it, study it, rationalize it, make the ice table because you have an equilibrium system, write the equilibrium law, make the approximation to make your life easier, solve for X, and then go from there.